Hey, kid again. This year IB is finally over. Congratulations for all the students. You know, your hard work. I don't know, I assume you have worked hard. It's finally paid off. And well, enjoy the rest of your life. And if you're doing IB first year this year, well, exactly 1 year later, these will be yours, okay? So keep your hard work again. Well, it's just after the IB, I thought I would take a break, you know, maybe start making some videos for a little bit, maybe a month or so. But I have got a request to break down two questions from 2012, okay? He's an HL student, I believe, and both questions are on paper 1 and happens to be two questions that I wanted to do a breakdown on, okay, a while ago. So, well, I guess I would just do a quick breakdown on them, okay, before I take my holiday. Okay, so I will do these two questions. Start with section A question first. So it's basically a time zone 1 question for this 2012 paper 1 question 9, okay? This is basically one of the hardest questions of this whole year of 2012. Is, if I'm right, the first time that they have asked something like this, which is a bit challenging. So I don't think too many students can get full mark for this question, but I guess you get some mark, and well, you will see. We will see how we do this. So we have a curve 2x squared plus y squared plus 18. You are supposed to find the coordinates of 4 points that are on C, on the curve C, where the normal would eventually pass through the point 1, 0. Okay, now this is quite tough. It's quite tough. First of all, you may not have the knowledge to know that what kind of stuff this curve represents, okay, which is not necessary. I can tell you basically a ellipse. Well, 1, 0, well, whatever. Then you're supposed to find 4 points where the normals all pass through that point, okay? So it's roughly like this. And the process is quite long. So this is what we do step by step, okay? So the first question is always, how do we find normals? Okay? How to find normals? To find the equation of a normal, you have to first find the gradient of the normal. To find the gradient of the normal, you have to do differentiation. You'll find dy dx over this equation. So the equation itself is 2x squared plus y squared equal to 18, and you have, if you have knowledge of implicit differentiation, right, you would know that you're supposed to do that. So how do you do implicit differentiation? Differentiate 2x squared is 4x plus y squared. For the square, you drop it down to 2y. But after you differentiate the power, you're supposed to do something like chain rule and differentiate y. But you don't know what y is, so all you can do is dy dx. Okay, you can 18 differentiate 18 is 0. That's the first place you can make a mistake. So this is supposed to be 0. Okay, for implicit function, let me do a quick explanation. This is basically chain rule y, because if you say, imagine you're integrating cosine square, what would you do? Okay, I hope you're familiar with this. You would drop the 2 down, then cosine, okay, times differentiate the cosine. So differentiate cosine is negative sine. So differentiating y squared with respect to x is exactly the same. So you drop the 2, okay, y, and then you are supposed to differentiate the y, except you really can't because you don't know what y is. So you're stuck with writing dy dx, saying, well, I kind of wanted to differentiate it, but I can't. Okay? So implicit differentiation, the next step is you need to isolate this dy dx. So dy dx equal to minus 4x divided 2y negative 2x over y. Okay? The next, you're supposed to find the coordinates of 4 points, okay, points on C where the normal pass through this point. So from differentiation, you have found the gradient of the tangent, okay? And if you know the relationship between, okay, the tangent and the normal, you will know that they're perpendicular to each other, which means if you multiply those gradients together, it's supposed to be -1. Therefore, the slope of the gradient, the slope, the gradient of the normal, say is m times negative 2x over y is supposed to be negative 1. Solving this equation, we have, m being y over 2x. Okay? Now, after you have the gradient, you're supposed to do the equation of the normal. Now you can do it how? Okay, you're supposed to do something like y equal to mx plus c, and then put the m in. Now this is, you see some problem. Can we just put y for 2x in? Well, it would cause some problem because the fact that, well, we cancel the x. Okay, so this is the second place if you make a mistake and you just get so stuck and there is no way to go. Actually, you have to assume this point. So assume the point be something else, because you can't keep using x and y, because what will result is you would cancel the x. So assume the point be, say, AB. And then we need to first plug AB into this gradient function. It's same as if I tell you, okay, that I'm looking for the gradient of y equal to x squared. You differentiate it, you say it's 2x. You can't actually use this 2x to find the equation of tangent. Okay, you wouldn't do something like y equal to 2x x plus c. Okay, you have to give me your point, say it's 2, I plug it in, becomes 4, then I use y equal to 4x plus c, etc., etc., right? Therefore, we need to assume a point because they don't give me any points, right? So I let this be my point. Therefore, the gradient would really be b over 2a. b is y, a is x. Therefore, the equation of normal is y equal to m x plus c. Normal procedure, how do you find c? You plug the point back into x and y to try to find c. So what's y? Y is b, and then x is a. Okay, so a and a cancel out, so it's b equal to b over 2 equal to c. So c is b minus half b, so it's half b. Therefore, the equation of normal for this curve is supposed to fit the equation b over 2ax plus c. C is b over 2. Okay, this would be a general form of all equations of normals that pass through this equation. Okay, with ab a point on this equation. Now, the normal is required to pass through the point 1, 0. So theoretically, 1, 0 must be on this line. Okay, so we can actually plug 1, 0 in. Okay, you understand? Because the tangent itself is supposed to pass through 1, 0. So plug it in, 0, 1. Okay. B over 2. Okay, we add them up a little bit. Okay. So it's 2a. Okay. We can multiply this 2a to the other side, 0. 0 times anything is 0. So 0 equal to ab plus b. Okay. Look like this is the requirement for the normal to pass through 1, 0. So we're supposed to solve this equation, find the value of a and b that would do this. Okay, how do we do this? Well, of course, both of them have b, so we factor out b. Two things multiplied together get you 0, so b is 0, or a plus 1 is 0, so a equals to minus 1. Okay, so that's basically the answer. We let the point be ab, and so we get a conclusion that either a is -1 or b is 0. Okay, but the question says we're supposed to have 4 points. Wow, that's a lot of points. Do we actually have 4? Let's see. B is equal to 0. B is the y coordinate. Remember that. However, the equation is also given 2x squared plus y squared equal to 18. So let's try that. Substitute y being 0 to the equation. Okay. So what we got is 2x squared plus 0 squared equal to 18. Okay. We're running out of process. So what we got is x squared equals to 9. X is plus or minus 3. On the other hand, if a is -1, a is the x coordinate. So we have, okay, 2 -1 squared plus y squared equal to 18. This is 2 plus y squared equal to 18, y squared equal to 16, y is plus or minus 4. Okay, therefore, now we do have 4 points, so there are 3, b is 0, okay? 3, 0, negative 3, 0, or when x is negative 1, y is plus 4, or negative 4, 1, 2, 3, 4, with 4 points. They are the 4 points where the normal would somehow pass through the point 1, 0. This is a really tricky question. While the technically are all known to you, nothing is new, but yeah, see if you can do it, right? Okay, let's move on to the second answer because second question because I want this to be quick. Question 13 is extremely popular kind of question. They're testing this more and more. I don't know why. The definition of derivative, basically the first principle. And the good thing is it's already given. It's always given. So you have really no need to actually remember it, except you need to know how you use it. So you're supposed to use the definition of differentiation. So remember, this is developed by Newton and Leibniz independently. Yeah, it's the story of mathematics, right? The history of mathematics. Okay, nobody's interested. Okay, to show that, okay, if I differentiate this, okay, I would get this. Okay, we all know we get this, right? We know how to differentiate this. The question is why? How do we use the definition to show this? Then it's a mathematical induction question. Okay, both are not that hard. Okay, so let's see. Okay, let's start with the mathematical induction. Okay, so A. Let's do this. So differentiation limit h tends to 0, fx plus h minus fx over h, where fx would be the thing that we want to differentiate. So we want to differentiate 1 over 2x plus 1. Okay, I think we need a narrower marker here. Marker is kind of running out of ink. Sorry for that. So this is basically composite function. We plug x plus x inside here. It's 1 over 2 plus h plus 1 minus fx for h. Okay. Well, you can see that the stuff has started a little bit complicated. Okay, like this. I haven't really done this before, so I think I would, I don't know, get a common denominator, do the subtraction maybe. This to this, this to this. Minus bracket 2x plus 2h plus 1. Okay, what is this? You can still follow me, right? They are still nothing special yet. Okay, 2x minus 2x, that's gone. 1 minus 1, that's gone over 2h. Wow, this is easy. Oh, by the way, how do we compute this limit, right? The whole problem of this limit is when you have the denominator going to 0, you can't just plug 0 in to calculate your limit because anything over 0 is not allowed. It's undefined. So what we want to do is we want to spend as much as we can do to eliminate this denominator, the h from the denominator, which just by getting a common denominator, do a little bit of thing in the numerator, we get that done because h and h can now be cancelled out. Okay, so this is 2 over this big thing. Okay, notice that when x tends to 0 right now, all that have x is this term, this little thing here. So this goes to 0. So when x goes to 0, this is 2x plus 1 times 2x plus 1. Okay. Yeah, where's that? See, I missed a negative here. Negative 2x. Negative 2x. So this is a negative. Okay, negative. Yeah, make a mistake there. So this is the good thing about proofs. We know the answer, so we know when we make a mistake. Okay. Next part. mathematical induction. Okay, so we are supposed to find the nth derivative of this thing. Okay, mathematical induction. I've always wanted to do a special selection of mathematical induction. I don't know. You can tell me in the comments if you like that idea. When I was learning this, I didn't find this particularly hard. I find it easy actually because we always know the answer. Okay, so I kind of like this kind of question, but I don't know. After I've been teaching IB syllabus, a lot of students seem to have a little bit of problem with this. So I don't know. You tell me in the comment section if I should do a special selection after watching this. Maybe this is good enough. I don't know. Okay, mathematical induction. So we always start with n being the first case. While talking about derivative, of course, the first case is the first derivative. So we differentiate this thing once. Okay, of course, 3x plus 1 to the power of negative 1 is just this thing. We did it from part A already. Is this. Well, the right-hand side. Okay, so we are supposed to check when n is equal to 1, do the two results match? Okay, do the derivative of this, do the first derivative of this match with this given formula? So what we do is, first, on the left-hand side, we try to differentiate it as we can. On the right-hand side, we check when n equal to 1, do this formula agree with our correct answer? So 1, 2, 1, 1 factorial. You really want to be clear with your presentation because the marker knows that you know the answer is given. 1 factorial is 1. Therefore, if you skip too many steps, they will suspect that you have no idea what's going on and try to deduct your mark. So whenever it's proof question, you try to be careful. Okay, so see, okay, the same, of course. Next step, okay, after checking the n equal to 1 is true, we assume that there exists some k is some integer, that when n equal to k, okay, k is an integer. Okay, I'm running out of ink, really. Okay, let's try this. Okay, when n equal to k, the formula is correct. When the formula is true. Okay, what do you mean by the formula being true? I mean, if I actually differentiate this k times, okay, the kth derivative, okay, so the ky, the xk, okay, maybe not y, differentiate this bit by k time, the answer would actually be this formula with n being k. So negative 1k, okay, 2k, k factorial divided by 2x plus 1, k plus 1. Okay, so this is assumed to be true for some k, okay, like maybe k is 1000, we don't know, okay, it's just an assumption. After the assumption, we move on to the next k after k, so that is when n equal to k plus 1. What we need to do is we show that under this assumption, so we can use this, we assume this to be true. When we differentiate this, k plus 1 time, it would still agree with this formula. Agree means all you need to do is change the n's to k plus 1. So we start with that. So remember, when we prove something, we don't start with the answer. So although we know that the finally would be this, we can't write this at the beginning. It's supposed to be at the end. Okay, eventually we will reach that. So what we're going to do is we start with the k plus 1th derivative. And the most important thing about induction is how do you use your assumption? How do you incorporate this into the next case? Now for this question, it's really easy. This is the k plus 1 derivative. How do you get the k plus 1 derivative? You find the k derivative and then differentiate that again. So all you do is you differentiate this again. Okay, how do you differentiate this thing, right? Look, the k is an integer, a fixed number, a constant, just some kind of integer. Negative 1 to some power k is a number. 2 to the power of k is still a number. Number factorial is still a number. They are all useless. They have no x in it. So they're all constant. Sorry, not constant. They are all coefficients, right? So when you differentiate stuff that have coefficient, You just leave them alone. All you need to do is differentiate this little part. Okay? So all you need to do is copy this and think about how to differentiate the bottom. So usually what we do is we write the denominator in negative index form. Oh, sorry. And then differentiate that. So we're going to copy all these coefficients. And then differentiate this. How to differentiate this? You drop this down. So it's negative k plus 1. 2x plus 1. You have this minus 1. So negative k plus 1 minus 1. And then chain rule. Go inside this 2x plus 1, differentiate it. We get a 2. So then multiply by 2. Okay? Don't miss anything. It's going to get it wrong. Well, but even if you make a mistake, you would know because we know the answer. That's a good thing. So negative 1 to the power of k times 1 more negative 1. So that gives you negative k plus 1 to the power of k plus 1. 2 to the power of k times another 2. So 2 to the power of k plus 1. Okay? Remember this negative gone into this negative 1 already. This is k factorial times k plus 1. Of course, that's supposed to be k plus 1. Oh, no. This is multiplication. K plus 1 factorial. Right? Okay, bear that in mind. Supposed to know this. And then we have this thing is 2k plus 1, 2x plus 1 to the power of, what is this? This is, if we put the negative in, okay, we put the negative in here, it's negative k minus 1 again. So it's negative k minus 2. Negative k minus 2. We pull the negative out, so it's negative k plus 2. Negative k plus 2. Wow, what's the meaning of negative power? Right? Negative power means we can put that into the denominator, 2x plus 1 to the power of k plus 2. Do this agree with our formula? Okay. Negative 1 to the power of n is k plus 1, good. 2 to the power of k plus 1 factorial, 2x plus 1, k plus 1 plus 1. Okay, k plus 1 plus 1 is, of course, k plus 2. Done! Okay, is it done? No, not really. We still have a passage to go on. Okay, yeah, technical problem. That bears some mark. Okay, yeah, I'm gonna need to... should I write this once? Okay, maybe once. Okay. Okay, this is what you're gonna say. Therefore, if the case for n equal to k is true, the case, this is case, for n equal to k plus 1 is also true. Therefore, by mathematical induction, the case, now you copy the question, right? The nth derivative of 2x plus 1 to the power of negative 1 is this thing. Okay? Yeah. Basically, here you copy the answer, copy the question. Okay? Remember this. This bears 1 mark. Okay? And this is why I love this, you know. Doing the n equal to 1 thing, it's easy. You plug 1 in on both sides, always agree. That's 1 mark. Writing this assumed thing, that's another mark. Okay? I don't know if you can do this, but writing this again, another mark. So I really like this. It's like a giveaway. And if you have enough practice, this process is not hard at all. So this is it. Remember to comment and maybe like, maybe subscribe if you like my videos, like my explanation. And if you want to do any breakdowns at all, send me, you can just comment me, you know, in the video. I read all the comments. They're actually not a lot, by the way. I really encourage you people to comment more. You can just make a request down there. Give me some idea on what to do in the future. Tell me if you like them. Tell me if I make mistakes. I'm sure I make a lot of mistakes during my video. I hope it wouldn't make you misunderstood some points. So that's it, you know. Comment more. I would like that, you know. Bye.